Hi everyone, I'm TigerHawk23, and today we're going to take some time to look at time, which is Python's standard library module for working with time, which you might need sometimes. That's enough of that. Okay. Slightly longish module. Let's see what we can do. Sometimes I say that it'll be a multi-part stream. I have to start Python first, and then we do it in one part. So let's see. Terminology and conventions. An epoch means the point where time begins according to any given system. The standard is what Unix uses, which is January 1st, midnight of 1970. Because. Some functions may not handle dates and times before the epoch, or far in the future. Generally no Y2K issues. Explanation for that. Maybe some of you younger viewers aren't familiar with this. 30-ish years ago, people would write programs that handled a year value, and they just do like 83 or 95 because it was like 1983 or 1995 or whatever. And that worked fine, except that in the year 2000 it goes to 0, which is before the numbers 83 or 95 or whatever. So the idea was that as soon as 1999 ends, everything will break. But actually it was maybe everything that looks at time will break, or everything that looks at time and doesn't handle it properly will break. What happened was some people and companies had to do a lot of work to fix all their code that was kept running longer than it should have been. Maybe they thought, we'll use this for a few months and that's it, but no, it's going to be running for 20 years. Not running consistently, but people are still going to be using it, and then it's going to have a problem. So some people had to do more work, and generally speaking, I think it got done in time. I didn't hear of any actual problems. People thought it was the end of the world. It wasn't. UTC means Coordinated Universal Time. Also GMT, Greenwich Mean Time. It's the standard time zone, basically. DST is Daylight Saving Time. Some areas change the time by half an hour or an hour when it's summer, so you can get more daylight into the day while still using the same number values for your schedule. Like if you generally wake up at 8, you get to the summer and it's been light starting at 7, maybe. So you say, okay, instead of 8 o'clock now, we're going to call this, you know, we're going to call it 9. So you keep waking up at 8, but you actually have to wake up an hour earlier. That's spring forward, is what it's known as, and it reverts in the fall. So you spring forward and you fall back. This is actually not really Python related, it's time related. Precision of time and sleep is better than their Unix equivalents. 9 integers, blah blah blah. Okay. Functions. Here's one. when you have an alternate time zone within a time zone, meaning daylight saving time. This is a function, I think. Oh, sorry. The offset of the local daylight saving time zone in seconds west of UTC, if one is defined. My time zone is usually 8 hours behind, so 8 times 3600 equals, usually it's 28.8, but 25,200 divided by 3600 is 7. So that's a 7-hour difference instead during daylight saving time. Time.asc, time, convert a tuple or struct time representing a time as returned by GM time or local time to a string. Let's look at those when we get to them, shall we? Time.clock. Pretty much 0. E-6 means with the decimal point 6 places to the left. Let's do it again. 9.9. Notice how it's about a second later each time. The first time you call it, it's 0, and then it just tells you how long it's been since the first time you called it. Unix, there's a bunch here that's only Unix. Availability, Solaris. Okay. Unix, Linux, that's unusual. Usually it just says Unix, but here it has Solaris specifically, and Linux 2628 or later. Interesting. Unix. Huh. Convert a time expressed in seconds. How about, did we go over this yet? They're not going to tell us. Oh, it's alphabetical. Time.time. This is the number of seconds with microseconds since the epoch, which is January 1st, 1970. So let's do time.ctime, time.time. So this says it converts a time expressed in seconds since the epoch, which is what time.time gives us, to a string representing local time. That's what time it is right now, over here where I am. Friday, August 12, midnight and 6 minutes and 34 seconds, 2016. Great. Time.daylight. 1, because, yes. Non-zero if a DST time zone is defined, and I'm in DST right now, so it's non-zero. Time.getClockInfo. What is this? Oh, name. Get information on the specified clock as a namespace object. What does that even... It says you can get info on the specified clock. So there's time.clock, which we looked at above. There's time.time. Why do we care about any of this? I don't. Let's skip that. GM time. Convert a time expressed in seconds since the epoch to a struct time in UTC, in which the DST flag is always 0. Time.gm time of time.time. And this gives us a struct time object, which we will go back and use on ASC time. And there's the time again. Great. AC time. So there's C time, and there's where's C time? So there was C time and ASC time. This just takes a number in seconds since the epoch, and this takes a struct time object, which this gives us. Fantastic. Tigerhawk, do we care about this? I don't know. It's the time module. I actually don't use this super often. I mostly use it for performance measurement. If I want to see how long something takes, I will generally do something like TimeClock or something, or one of the other clocks that it has, and then run the function, whatever it is, and then do that clock again, or actually just print that function call minus the saved time. It's a very simple way of doing that. Let's try that. Actually, not yet. I have a better idea. Like GM time, it converts to local time. Time.local time. 2016, 8, 12, see, hour 7, hour 0, 7 hours ahead, meaning UTC, is, it's 7:07 UTC, well, 7:09 now, and midnight 09 local time. This is the inverse function of local time. Its argument, there's an MK time, which goes backwards from local time. Its argument is the struct time or full 9 tuple, which expresses the time in local time. GM, so local time, and I guess this is like ASC time. MK, is this right? Okay. Fantastic. Time.monotonic. And monotonic means it cannot go backwards. I don't know which can and why. Not affected by system clock updates. The reference point is undefined, so that the only difference between the results of consecutive calls is valid. You can't like just call time.monotonic once and expect it to mean anything. You're supposed to call it and save it, and then do, stuff, wait some time, and then call it again, and then you can calculate the difference. Time.monotonic minus this. I waited 34 seconds. Great. In 3.5, the function is now always available. Why wasn't it? I don't know. Perf counter, another clock. A performance counter. So that's great. It has the highest available resolution to measure a short duration. It does include time elapsed during sleep. That means while the thread is not running. And is system-wide. The reference point of the return value is undefined. Only the difference means anything. This minus that. It's been 23 seconds, whatever. Process time. Return the value of the sum of the system and user CPU time of the current process. Not very long. Okay, time.sleep. Here's a popular one. Let's say 3. Are you ready? 0, 1, 2, 3. That's what it does. It tells the thread to sleep. Suspend execution of the calling thread for the given number of seconds. So something to keep in mind is that this isn't just like a delay, it actually stops running things. If you have a print call right before this and then you sleep, it might not print whatever you thought. Sometimes people want like a timed printout with a delay, like for a timer or something, 98765. And that's because the output of the print function may be stored in a buffer and not immediately flushed. So for I in range 5, print I and time.sleep 1, 2, 3, 4, and that's it. Good, right? Now let's check out something else. Let's change the end to a space. And then do time.sleep 1. Now let's see what happens. Nothing, 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 everything. Do you know why that exploded in our face? Well, when you do a when you print a line feed, which the print function does automatically by default, because the default end character that it prints at the end of that call is a character turn, a line feed. So that gets flushed immediately. If you don't have one of those, it might not flush. So it's saying print this, but it's just sending the stuff that it wants to print to a buffer where it's kinda held until it knows that you want to actually do something with it. So it's holding on to it, and then it prints it, puts it in the buffer, and then you tell it to sleep and wait, and then you print and it's still in the buffer, and you tell it to sleep and wait, so on and so forth, and then eventually it's done. It's like, okay, I'll flush the buffer now, and then you get everything. How do we avoid that? We start a new line first, and we say this, and there's an argument to the print function, very handy. In Python 2, we would have to use import sys, and then do sys.standardout.flush. But here we can just go flush equals true. Time.sleep 1, and then an empty print call. No, I don't want it after every thingy. So let's do that. 0, 1, 2, 3, and 4, and we're done. Now it works great. Don't use time.sleep in a graphical interface program, something like tkinter, for example, because that actually stops everything. Like you won't be able to click on buttons or anything, and it might not have the timing that you want. In such a framework, you should use its built-in methods for scheduling stuff, like tkinter uses after. So it never sleeps, you just schedule a call and say after some amount of time, call this function. Because time.sleep doesn't work with those. Here we go. And there's a bug. Hang on. I didn't get it. Very tiny bug. My window has a screen. Makes sense, right? But the size, the pitch of the openings, the aperture pitch, is larger than some bugs. And any bugs that are smaller than that walk right in. It's really annoying. So I get bugs in my room all the time, even though I have a screen. Anyway, and since the monitors are warm, they fly in front of the monitors, and then they circle around and they fly in front of their monitors, so I get a every 30 seconds to a minute. It's awful. Anyway, time.string format time. Time.string format time. Format. You pass it a format and an optional time. If you don't provide the time, it uses the current time. Format time, I want it to have, let's give you an example. Okay. That's what it does. It basically, you might be familiar with the with this syntax. And that's string interpolation. So it's doing something similar. This %y means we're going to interpolate into this place the year as a 4-digit number. Is that 0 padded? There's dozens of this, of various things. Year with century as decimal number. Okay. %h, a capital H, is the hour with a 24-hour clock. So from 0 to 23. If you want a 12-hour with 1 to 12, you do %capital I. Capital M is minutes. Yes, minutes. Lowercase m is the month, so keep that in mind. Capital S is seconds. Is lowercase s something? I don't see anything. There's a bunch of stuff you can do. Locale's abbreviated weekday name. The name of the weekday abbreviated. Not abbreviated. The abbreviated, let's do the full month and the abbreviated month. That's great. Locale's appropriate date and time representation. Cool. That's a nice little shortcut. Lots of this stuff. The month, the AM or PM, the second, the week number of the year from 0 to 53. The weekday, the week number, blah blah blah. Appropriate date representation. And appropriate time representation. Year without century, year with century, time zone offset, time zone name. Does that work? Neat. Pacific Daylight Time. That's what it is. And the way you escape a % is, say we have %, and then this. Doubling them up results in a single literal. Blah, 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 blah. And now what if we have something, we went from a time, blah, blah. We went from a tuple or struct time representing the time to a string. What if we have a string and we want to go to a time? So we can go backwards. String p time. Let's get this whole thing. Thank you. What if we don't format it? What do we get? Nothing. Oh, it's the wrong... Okay. And A is... Okay, I must have... yeah, that's the wrong... I need to enter a format. It doesn't like that. So the default one is this, whatever that is. And I don't have that. I'm not using it. So I'm going to say we have the month slash the day slash the year with only 2 digits, and a space, and then hour, minute, second. All right. And there's our struct time object. Fantastic. 2016, 8/12, hour 0, minute 21. It continues on with the second, the weekday, the year day, and whether it's daylight saving time. And I have -1 for that, which is non-zero. That's fine. So what else can we do? String p time. It's pretty handy if you're analyzing like a text file with logs or something. Did I use this for? I think I used this or the one in DateTime. There's the DateTime module, which also is kind of expanded and works with dates as well. That is very handy. I think I did use it. Something like this. If you have a log or an Excel file or something, or a CSV, I mean, you would maybe use it in conjunction with the CSV module, which we looked at last time, and then you could get actual time objects out of it. I think DateTime is better. It's more complete. There's a class of struct time, which is a named tuple interface. That's great. Time.time, I think we already looked at that. Return the time in seconds. Time.timezone, I think we already did that as well. Yep. Time.tz name. Pacific Standard Time and Pacific Daylight Time. The local non-DST time zone and the local DST time zone. TC set resets the time conversion rules. No. Oh, availability Unix. Great. And we're done. The use of %Z is deprecated. Oh, the time zone name. So in the string format time, the %Z descriptor is not supposed to be used anymore. And that's the time zone name, which produces no characters if no time zone exists. Standards, things. Okay, that's mostly, not just mostly. That's it. Things you will likely see and or use. Time.sleep. If you're writing a little console program and you want some kind of timer with a delay instead of just printing out everything at once, be very careful about doing that. It's not necessarily good to make your users wait for no reason other than this is cool. For example, if you have some kind of presentation that you're going to give, maybe PowerPoint or something, and any format really, don't animate the pages. If you want to say we're going to the next slide or the next page, don't put a big beautiful turning the page, because the only reason for that is to show that you are able to animate a page turning, and unless you're actually the one who made it, it doesn't actually matter. This is, look, someone else made something cool. That's great. But all I want to do is see the presentation and not wait for like 5 seconds all the time. There's no point. So be very careful with time.sleep, because it's not actually doing or calculating anything while it does that. So make sure the delay is reasonable and expected and makes sense. Like if you want to give someone time to read stuff, might be better to just stick an input call in there so they can press enter, or use another library called curses, I think. There's ways to get the terminal to basically allow scrolling up and down, but not like the actual scroll bar of the window, but like press space to move to the next screen and you can go back, etc. Maybe something like that would be better. But if you want something basic, time.sleep. Or if you just want a shutting down in, 5, 4, 3, whatever, that could be good. What else is there? Clock. The various clocks. Time, clock, monotonic, perf counter. Very handy for doing a quick, simple performance test. There are other ways to do that, like the TimeIt. I think it's a library, an entire module. Is it? Yeah, TimeIt is a full module. Measure execution time of small code snippets. That's a good one. We'll probably look at that eventually. But yeah, monotonic and perf counter is pretty easy to use. String format time and string parse time. When you have struct time objects that you want to turn into a string with your own formatting, and string parse time when you have strings with some kind of specific formatting and you want to turn them into struct time objects. Keep in mind the DateTime library is much more complete and allows you to do a lot more interesting stuff. So whenever I want to do actual time calculations, I use DateTime, because yeah. Alright, not a super long stream, but there's some good stuff. Clock, monotonic, and perf counter, all pretty similar. And sleep, and the format and parse time. Those are the big things that you'll probably use if you use this library. Tomorrow, I have a feeling I'm going to be doing more trucking in Europe. Day after that, arc parse. I don't know if I want to. Curses, terminal handling for character cell displays. I don't think I want to. Threading, multiprocessing. I don't know how to use those. I don't understand how to. There's lots of boilerplate stuff you gotta write. Like someone makes a minimal example of something with threading or multiprocessing, and it's like 50 lines long for all the stuff they have to set up. Networking, goodness. Data handling, email, JSON, mailcap, mailbox. Something in here, I guess. HTML, XML, URL lib, that's a good one. I don't know. We'll see what we get to. But, something. So that's today's stream. Join me tomorrow and on subsequent days for more cool stuff. And that is all. Thanks, and have a good one.